Hello everyone and welcome back to the course. In today's lesson, we're going to talk about periodicity and symmetry of periodic functions. Let us consider the function y equals sine of x, and let us also consider the horizontal line y equals 0.5. As you can notice, there are several points of intersection between this horizontal line and the function y equals sine of x. As a matter of fact, there is an infinite amount of points of intersection between these two graphs. Let us find the coordinates of all of these points of intersection. The first point that we can find it by solving the equation sine of x equals to 0.5. Now, if we apply the inverse of sine both sides of the equation, meaning arc sine of x both sides of the equation, we get that x is equal to arc sine of 0.5, which is equal to pi over 6. Now, as sine is a periodic function, we know that its period is 2 pi. Therefore, all of the values repeat themselves every 2 pi. Thus, the points of intersections that we can get from the first solution and the periodicity can be gotten by the equation x equal pi over 6 plus 2k pi, where k is an integer. Nevertheless, we're not finding all of the points of intersection. Right beside x equal pi over 6, there's another point which is not part of the general formula, as you can notice in the graph. So a natural question arises: how can we find it? Well, y equals sine of x is a function that is symmetric about pi, meaning that sine of pi minus x is equal to sine of x. Thus, for finding the other solutions, we need to solve this new equation. Sine of pi minus x is equal to 0.5. Thus, if we apply the inverse of sine, we get that pi minus x is equal to arc sine of 0.5. Therefore, if we solve for x, we get that x is equal to pi minus arc sine of 0.5, which we know is equal to pi over 6. Thus, x is equal to 5 pi over 6. Therefore, all solutions of sine of x equals 0.5 are the following: x equal pi over 6 plus 2k pi, where k is an integer, and 5 pi over 6 plus 2k pi, where k is an integer. In the next section, we will solve general trigonometric equations. But before getting there, we need to know the periodicity and symmetry of the remaining trigonometric functions, meaning cosine and tangent. Let us understand the periodicity and symmetry of the function cosine of x. Cosine of x is a function which period is also 2 pi. But this function is an even function, meaning that cosine of x is equal to cosine of minus x. So, if we want to find out when cosine of x is equal to 0.7, then the principal value will be x equal to arc cosine of 0.7 if we apply the inverse of cosine both sides of the equation. Thus, x is approximately 0.79539883. The other value we can find within one period is by solving the equation cosine of minus x equal 0.7. Thus, if we apply the inverse of cosine, we get that minus x is equal to arc cosine of 0.7, which we already know its value, but we need to multiply by negative both sides of the equation, and the solution will be x equal to minus 0.79539883. Thus, the general solution for getting of the points of intersections, which we know they are infinite, is by considering x equal to plus or minus 0.79539883 plus 2k pi, where k is an integer. Remember that we need to add this number because the period of cosine is also 2 pi. Finally, let us understand the periodicity and symmetry of the function tangent of x. Tangent of x is a function which period is pi, and it is not symmetric at all. Thus, if we have an equation like tangent of x equal 10, then for finding all of the solutions, we only need to do x equal arctangent of 10 plus k pi, where k is an integer. Remember that in the equation tangent of x equal 10, we need to apply the inverse of tangent both sides of the equation, and then we need to add a multiple of the period, and x will provide all solutions. Well guys, that's it for today. Thank you very much for following the video until its very end. Now it is time for you to put your knowledge into practice by solving the following trigonometric equations. Remember to do the analysis on periodicity and also on symmetry. And well guys, as always, see you in the next video.